Okay guys, so today we're going to be doing factoring expressions, and we're going to be using the distributive property as well. Okay, now I'm going to go fast because I want to make sure that you guys get all this. I want to make sure that we understand how we do the factoring of the expressions. So what I'm going to do is I'm going to model some tricks here, and I hope you look at them. Okay, so let's say we have this, which are going to be a two sections. It's a model that has, say we have a 5. So we have a 5, a 5, and a 3, and a 3. Okay, if we do this, then what we will end up with over here will be 2 5s actually, right? So 2 times 5, or 5 plus 5, and 3, or 2 times 3, 2 times 3, or 3 plus 3, either way. And so all of this, if you add it all together, 5 plus 5 plus 3 plus 3, you will get a total of 18. But there's different ways to write this. This is one way to write this, 5 plus 5 plus 3 plus 3. There's another way. One is 2 times 5 plus 2 times 3, which also will give you 18, because you will do 2 times 5 equals 10, and 2 times 3 would equal 6. Actually, 16, I'm sorry. This will be 16. And this will also give you 16, because it'll be 10 plus 6, okay? Another way to write this could be 2 times 5 plus 3. Why? Because 5 plus 3 equals 8, right? And 2 times 8 equals 16. So many different ways that we can rewrite, because we know we have 2 5s and we have 2 3s. So many different ways in which we can write equivalent expressions. So we call this equivalent. This one is equivalent to this one. This one is equivalent to this one, because they all come with the same answer, which is, in this case, 16. So let's say we got a similar problem like that, okay? And the problem looks very similar, but now we're going to mix it up a little. So let's say we have this same model, okay? A little bit more crooked, but so let's say we have this model now, and in this model you have the 5 here, you have the 3 here, and then the 5 and the 3 here. Similar model, but now you have something a little bit different, because this is actually a 5 plus 3 here and a 5 plus 3 here. Still the same. We still have 2 5s and we have 2 3s. So we can do something similar, which would be 5 plus 3 plus 5 plus 3 still gives you 16. Over here we still have 2 5s plus 2 times 3, which is also 16, because 2 times 5 is 10, and the 2 times 3 is 6, okay? Also, this could be written as 2 times 5 plus 3, and is similar to this. So they're called equivalent expression, because this will be 2 times 8, which gives you 16. Equivalent expressions all around. This one is equivalent to this and to this. 3 different ways to write an expression, okay? Now we're gonna take a look at now different model. This one is going to have letters. So let's take a look at this model. So this model is going to look like this. So model with letters. Let's say it looks like this. And in the model, you're going to have an A, a B, and a B. And we're going to write three different ways to write this. We know that right here, from here to here, and from here to here, this will be A plus A, and this will be B plus B, okay? But we also know this as 2A, and this will be 2B, 2A, 2B, okay? Similar to what we did over here. They're equivalent because you can also get this as A plus B plus B. You add all of them together and you get a value. Now, in this case, we don't know what the value is, but we know it as 2A plus 2B, okay? In this case, we have 2A, so I'll equivalent to this 2A plus 2B, or we can also write it as 2A plus B. And they're all equal to each other. They're all equal to A plus 2B. They're equivalent expressions. So take a look at this. This 2AB is equivalent to this, and equivalent to that, okay? So no matter what numbers we're using, we're still finding equivalent expressions. So now, let me show you something similar again, using similar variables. In this case, we're going to use these two variables again, and didn't come out. So let me erase this, and let's redo this. So, okay. So we have now something similar, but now we have them a little bit more A and B mixed up a little, okay? So don't panic, it's still the same concept, same idea. So in this case, we're gonna get the A plus B, okay, equal to A plus, let me move this way, okay, A plus B, which is still equal to 2A plus 2B, right? Now, in this case, we're gonna get the A plus B plus A plus B, okay? Which, if you think about it, this one still gives you the same. It's 2A plus 2B, right? Because you get 1A plus 1A and 1B plus 1B. You get the 2A plus 2B. But also, this could be rewritten as 2 times A plus B, similar to 2A plus 2B. So no matter which way you put it, these are all what we call equivalent expressions, okay? Because they all have the same value, okay? So let's use this scenario to kind of bring something into perspective. So let's think that we have 3F, okay? Keeping in mind with the same thinking, 3F, and we have 3G, okay? So we have 3F and 3G. How will we rewrite it so that there is a parenthesis, okay, and something in there in those two, okay? The greatest common factor in these ones is going to be your 3. So 3 goes on the outside, and F and G stay on the inside. It's something similar to what we've seen over here, in which 2A plus 2B became 2A plus B, okay? So we're now getting into something new, which is called the factoring, okay? So let's take a look at this one now. 6x plus 9y, okay? This one also will have something like this, right? With a plus in between. But we have to be careful here because we have to find what the greatest common factor will be in this case. So one of the ways I do this is by multiplying 2 times 3. That's how I get 6. And then 9, I get 3 times 3. And that's how I get 9. So how I identify the greatest common factor is a number that is in here is also in here. In this case, it'll be a 3. So what's left over in here is your 2x, and your 3y. And if you check it, if you multiply this times this and this times this, you should get the same amount as this. So 3 times 2 is 6x, and 3 times 3 should give you the 9y. Those are the examples that we're gonna see. Now let me show you another example. 3c plus 11c. Okay. Now in this case, okay, the greatest common factor is very obvious, but some people may not see it. But let's say 3, boy, I cannot multiply 3 times anything. I just get 3 times c, and in this case also 11 times c. So the only thing in common in this case is c. So c goes on the outside, and inside we get 3 plus 11. And that's how we rewrite this. That's the greatest common factor, okay? One last example I'm going to show you, and then you're going to be on your own. This will be a 24b plus 8, okay? Let's think about this. How would you factor this out, okay? In this case, 24 is factored as 2 times 2 times 2 times 3. I factor 8 as 2 times 2 times 2. Okay? Now you see there's a 2 here, there's a 2 here, there's a 2 here, another 2 here, another 2 here, and another 2 here. So this altogether is going to be 8, and this is going to be 8. So the greatest common factor of these two things, oh, I forgot the b here, sorry. In this case, it's going to be 8, right? And on the first term, I have 3b left. And on the second term, well, I don't have anything left, so I leave it at 1 right here, okay? So that when I multiply this times this, I get 24b. And when I multiply 8 times 1, I get 8, okay? So that's how we do the factoring, okay? The factoring is getting this greatest common factor and factoring it out. You're going to do something similar in your homework when I post it tonight, okay? So make sure you do that.